sides. I can solve algebraic equations with variables on both sides of the equal sign, or the equation. So think of a teeter-totter, with the equals being the middle. So remember, this means I have two groups of x plus 3. So I have an x plus 3 and another x plus 3 on this side. On this side, I have 4 x's and a plus 2. So if we want to put these together on this side, I would have 2 x's plus 6. And that's our distributive property. So I'm going to rewrite this as 2 x's and a 6. Because remember, that would be 2x and that would be 6. So now I want to keep the teeter-totter balanced at all times. So I need to think about if x's were like friends and they're jumping off. And then they have a 6-pound weight, and this one has a 2-pound weight to make sure it's balanced. Well, let's make a friend jump off of this side. Well, if one jumps off here, one definitely has to jump off here. Now they stay balanced. If one jumps off here, one has to jump off here for them to stay balanced. So right now I have at 2 x's and a 2-pound weight balances out the 6. So let's get rid of this 2-pound weight. If that comes off, then how much of the 6 has to come off? Well, 2 pounds, which would give me 4. Which means each of these x's has to be 2 pounds each in order to equal that 4. So that's what we're going to think about today. So here are the steps to solving these. Like before, we always do the distributive property first. Then we're going to combine our like terms on one side of the equal sign. We're then going to move the variables, and then we're going to solve. So we're going to draw our line down to pretend this is the balance. So we do this side first. I distribute. 3 times x is 3x. 3 times 2 is 6. And on this side, I have x plus 6. Now I can't combine alike terms because I can't go across that line. So the only way to get rid of it is going to be to subtract it or have it jump off. So I'm going to subtract from both sides. This is left with 2x plus 6. These cancel, and I'm left with 6. Now I can take the weights off of both sides. So minus 6 minus 6. I'm left with 2x equals 0. I still would need to divide by 2 to get x by itself. X equals 0. So let's check this to see if it's correct. If I plug in 0 for this x, I plug in 0. And for this x, I plug in 0. Well, order of operations says I do its in parentheses first. 0 plus 2 is 2. And 2 times 3 does give me 6. And 0 plus 6 is 6, so it checks out, and I know the 0 is correct. I want you to stop the video on this next one, and I want you to try it by yourself. And then when you're ready, start the video and check the answer. All right, welcome back. Let's take a look. So I'm going to do this side of the line first. 4 times x is 4x minus 4 times 5 is 20. So I've distributed. Then I go to this side and I say, well, I have an x plus 2 times x is 2x and 2 times 6 is plus 12. Now I'm going to combine terms. I can't take this x and bring it over here. I can only combine the ones that are on this line on this side and then this side. So I'm going to combine the 4x and the positive 3x, which gives me 7x, and then I'm left with minus 20. On this side I have an x and a positive 2x, which gives me 3x plus 12. Now I can move the variables. I'm going to always move the smaller one just to keep my answers in the positives right now. So 7x minus 3x gives me a positive 4x minus 20. These cancel, and I'm left with 12. Now I'm down to a two-step equation. So I'd add 20. 4x equals 32. Divide by 4. Divide by 4. X equals 8. All right, last kind is a verbal, a real-world verbal problem. It says UPS charges $7 for the first pound and 20 cents for each additional pound. FedEx charges $5 for the first pound and 30 cents for each additional pound. How many pounds P will it take for UPS and FedEx to cost the same? So basically what they're saying is the UPS and the FedEx, we want them to be equal. So UPS charges $7 for the first pound and 20 cents for each additional pound. That has to equal the same that FedEx charges $5 for the first pound, but 30 cents for each additional pound. So we solve the same. There's nothing to distribute, there's nothing to combine, so we just move our variables. I'm going to move the 20 because it's smaller and I want to stay in the positive, 20 cents per pound. These cancel, I'm left with the $7 equals 5 plus 10 cents per pound. So let's move the constant, the 5. I'm left with 2 equals 10 cents per pound. So then I'm going to divide by 10, divide by the 10 cents. These cancel, and that leaves me 20 pounds. So in order for them to be equal, you would have to ship 20 pounds.